In 1999, RollerCoaster Tycoon was released to critical acclaim. While modern simulation games often struggle with frame rates once a few hundred guests enter the park, RCT handled thousands of individual AI agents on hardware that had less processing power than your modern smartwatch. We are talking about a Pentium 2 processor and 32 megabytes of RAM. Today, a simple chat application can easily consume hundreds of megabytes of memory just to idle. The secret to this efficiency wasn't just clever algorithms, it was the language itself. Chris Sawyer wrote 99% of the game in x86 assembly. This allowed for a level of hardware intimacy that is almost non-existent in modern development. Let's look at the sheer scale of this efficiency gap.
To understand why this matters, we have to look at the metal. Most modern apps are built using high-level languages like JavaScript, Python, or even C#. These languages provide safety and developer speed, but they come with an abstraction tax. When you write code in a high-level language, it goes through multiple layers, compilers, virtual machines, and garbage collectors before it ever hits the CPU. In assembly, there's no translation. You are speaking the CPU's native tongue. You aren't telling the computer to find an object, you are telling it to move the value at memory address A into register B. This direct control allowed Sawyer to optimize every single instruction for the specific cycles of the 80s and 90s processors, squeezing every drop of performance out of the silicon.
One of the biggest performance killers in modern software is the cache mess. Modern CPUs are incredibly fast, but fetching data from RAM is relatively slow. To compensate, CPUs use a tiny amount of hyperfast memory called a cache. Modern object-oriented languages often scatter data all over your RAM. When the CPU tries to find a guest's coordinates, it might have to jump to a completely different memory address, forcing it to wait for the RAM to respond. In RCT, because the memory was managed manually, data was packed tightly together. When the CPU loaded one guest's data, the next 10 guests were likely already in the cache. This is called spatial locality. It's the difference between finding a book in a neatly organized shelf versus searching an entire library where books are thrown randomly on the floor.
Assembly is so fast, why don't we use it for everything today? The answer is complexity. Writing in assembly is like building a skyscraper using only a tweezers and a magnifying glass. Chris Sawyer wrote roughly 1.2 million lines of assembly for RollerCoaster Tycoon. To put that in perspective, a single mistake, one wrong memory address, wouldn't just lead to a bug, it would crash the entire operating system. There were no safety nets, no automatic memory management, and no modern debugging tools. This level of dedication is nearly impossible in a modern corporate environment where speed to market is the primary metric. We've traded execution speed for developer velocity. We use Electron and heavy frameworks because they allow us to build features in weeks instead of years.
Let's visualize a modern app's hello world. To display a single line of text, a modern desktop app might bundle an entire web browser engine like Chromium. That's millions of lines of code just to provide the UI layer. Then you have the JavaScript engine, the garbage collector, the operating system's abstraction layer, and finally, the hardware drivers. Each layer adds a small amount of latency. In RCT, the code was so close to the hardware that it could bypass these bottlenecks entirely. It didn't need a rendering engine because Sawyer wrote the rendering routines himself, optimized for the specific way the CPU handles graphics data. We've gained cross-platform compatibility and safety, but we've lost the lean, mean efficiency of the late 90s.
RollerCoaster Tycoon stands as a monument to what is possible when we stop treating hardware as an abstract black box. While we'll likely never return to writing million-line assembly games, the principles of RCT still apply. Understanding memory layout, minimizing abstractions, and respecting the CPU's cache can make modern high-level code run 10 times faster. Performance isn't just a feature, it's a fundamental part of the user experience. The next time your computer fans spin up just to open a simple document, remember that 25 years ago, a single man built a world with 10,000 people in it, all running on a fraction of the power. Efficiency is magic.